We're going to solve one variable equation with fractions. In this version, what we're going to do is we're going to get a common denominator. We'll use a common denominator. That way it's a fraction the whole way through, and then see if we can't solve it from there. So in order to get a common denominator, we got to take a look at the denominators on each of the fractions. We need to find all the multiples of these. So multiples are just what we call them the multiplication facts of each of those values are, okay? So if we're finding multiplication facts of 5, you would have 5, 10, 15, 20, 25, 30, 35, okay? And it keeps going on. Sometimes it can take a while to find a common multiple of each of these. They usually call it a lowest common multiple, the LCM, okay? We have 2. 2 goes up quite a bit. 2, 4, 6, 8, 10, 12, and it goes on and so on. And 3, we get 3, 6, 9, 12, 15. Okay. This one's tricky. It's hard to see what the answer is going to be. When we look down at what I've listed so far, I don't have an answer. I know what the answer is going to be off the top of my head here. A fast way to do this, it's not always going to find the lowest one, but it can find a common multiple, is to actually take all 3 of them and multiply them by each other. So if I just say, hey, you know what is 5 times 2 times 3? It turns out 5 times 2 is 10, times 3 is 30. 30 will work. Turns out that 30 is a multiple of 3, it's a multiple of 2, and it's a multiple of 5. It doesn't always guarantee us the lowest. In this case, it happens to be the lowest if we check them all out, but that doesn't always guarantee the lowest that process. So just keep that in mind if you need to have the lowest common multiple. All right, so we found the common denominator here. We're going to use 30. Now here's the tricky part, is converting everything. We have 3x minus 8 over 5 is equal to 2x minus 1 over 2 plus 5 over 3. Each of these fractions are going to have to be multiplied by different numbers to get a denominator of 30. So we could use a little mental division here. 30. How do I make 5 into 30? Well, actually, I multiply by 6. And whatever I do to the bottom of a fraction, I must do to the top. Same thing down here. 2's got to turn into 30. What happens? 2 times 15 will give us 30. Whatever we do to the bottom, we have to do to the top. And same idea, 3 times 10, that one's a little easier. So we need to multiply this by 10. So let's go down here. I know my denominator is going to be 30 for all 3 of my terms, which is really nice. It's that multiplication piece of the numerator that's going to be tricky. Looks like we need quite a bit of distributive property here. 6 times 3x is going to be 18x. And 6 times negative 8 happens to be negative 48. Okay. 15 times 2 gives us 30x. 15 times negative 1 is negative 15. And 5 times 10 is 50. Well, now we have a common denominator. I can put these 2 terms together here. Okay. If we put both these terms together, what we end up with is 18x minus 48 over 30 is equal to everything over 30, 3x minus 15 plus 50. Okay, I'm going to simplify the numerator here. It happens to be already simplified here because I don't have any like terms in the numerator and the denominator is just 1 term. So the left-hand side we leave. Just kind of carry it down. The right-hand side, I can get my like terms. So the like terms happen to be negative 15 and 50. So if I subtract 15 from 50, I will end up with 35. So positive 35 over 30. Okay. Now let's take a look here. There's a couple of roots we can do. This is what's neat about math. You can take lots of different roots to the same answer. I can very simply get rid of all my fractions again. I have a common denominator here of 30. I can do this one little trick. You know what I'll do? We'll do both versions. I'm going to give you version 1, we'll call it. Okay, and then we'll give you version 2. I would personally take version 1. In version 1, we have a common denominator of 30 on both sides. So in other words, both sides of the equations are being divided by 30, which means I can apply the same operations to both sides of multiplying by 30, and all that does is cancel out all of the bottoms, and we end up with 18x minus 48 is equal to 3x plus 35. Even I like that better. Or we can do this in version 2. We're going to keep our fractions, but we're actually going to have to do a bit of splitting of them. Why don't I get us to the bottom of version 1, and then I'll take us through version 2. So I'll pick up the speed to get to the answer here. I need like terms, and I need x by itself on one side. So I'm going to put that over there, 3x to there, and I'm going to bring 48 over. This will leave us with 18x minus 3x is equal to 35 plus 48. This will give me 15x is equal to 83. That's different than the last time I did this. Give it a quick check here. We did this 2 seconds ago. Didn't I get 12? I'm up 48 over. I've made an error somewhere along the line here. I don't know where yet, though. Interesting. Okay, I'm going to go back. This is okay. This will end up giving us x is equal to 83 over 15. Okay. Version 2. In version 2, let's see if we get the same answer here. It's possible I've kind of jumped the gun and made a little error with my addition or subtraction or forgot a negative sign. In version 2, we have the same question, but what we're going to do, instead of having it a common numerator, like it's all one numerator, we're actually going to split everything up into an individual fraction so we can work with them as individual terms. So what does that mean? That means I'm going to get 18 over 30x minus 48 over 30. So you notice they kind of look like their own terms. I also have 3 over 30x plus 35 over 30. Okay? Yeah, that looks right on the other side. Same idea. I need to get collect common terms here. So I have the coefficients with x. I'm going to need to move this one over. And then my constant terms, I'm going to need to move these ones over. So I'm going to do that. So the 18 over 30x is going to be subtract 3 over 30x. And on the right-hand side, we're left with 35 over 30 plus 48 over 30. Okay? Because they're common denominators, we can just go ahead and add or subtract the fractions there. So we have 18 minus 3 becomes 15 over 30x. And this one here comes 83 over 30. Okay? Now to isolate for x, we have a fraction here. So technically to divide by a fraction, if I were to say, well, you know what, this is technically multiplied by x, so I should divide by 15 over 30. I'm going to write it like this. So let's divide by 15 over 30. When we write fractions divided by fractions that look like fractions, like this version here, they're stacked on top of each other, it's difficult to see. It's a little easier to see this because there's a little trick with our fraction rules. Luckily on the left-hand side, that eliminates. That's why we did it, so we're left with just x. Over here, to divide fractions, we invert and multiply, they say. That's the trick to it. So you actually invert this, so it becomes 30 over 15, and we multiply instead. And when we multiply fractions, you do numerator by the numerator, denominator by the denominator. I will tell you without going into too much math, technically these little things cancel out to make it simpler, and you're left with 83 over 15, which is exactly what I found before there. We have to turn into a mixed fraction. I wonder if I made a little error up here when I move things around. It's possible I did. I get the feeling I either added or subtracted by 3 incorrectly somewhere in the process because Or on the previous one, the exact same thing, because my answer is 83 over 12, and this one's 83 over 15 here. These are all methods to get to the exact same answer, each of them having their own merit depending on what your strengths are, but very challenging when it's big fractions like this.